Good morning. This is Mr. Burns, CPDLF science instructor, and it is Monday, April 9th, and I'm bringing you the 31st weekly chemistry launch of the year. And that's something, we're up to 31 now. It's also April, so spring is here, and let's get out and enjoy things. I know we've even had some snow recently and some colder temperatures, but it's coming our way, for sure it is. And with that too, the end of the year is coming, as you know. So hang in there, continue to submit your work. I've been getting lots of work in, and that's good. Keep it up. I want to see you do well. Keep working hard, trying to be accurate with the lessons, and stay up with your calendars, your course calendars. You can do it. We don't only have something like 6 weeks left, so you can do it. All right, let's just look at what we did last week. We did a lesson called Alcohols, 4.4, Aldehydes, Acids, and Ketones, 4.5, Esters, 4.6, and you did a project called Allotropes, 4.7. Most of those have come in really well. You seem to understand that alcohols, aldehydes, acids, ketones, esters, they are all organic molecules. They all contain carbon. The difference in them is that they have different pieces, groups that go together, groups of carbon atoms and hydrogen atoms that always go together. Alcohols are, there's always an OH attached somewhere on a carbon chain. In fact, all of these are carbon chains with just different parts added onto them. I've gotten some interesting responses for allotropes as well. Allotropes are different ways that atoms can be connected to other atoms, to even, I mean, the same kind of atom, but connected in different ways, double bonds, triple bonds, that sort of thing. For example, graphite and diamond and ordinary carbon are all the same atom, okay? But the structure of how the atoms are bound together, as well as the use of double bonds and triple bonds and single bonds, that kind of thing, makes them all different, and they have very different properties. Diamond's the hardest material known to, the hardest natural material known to man. Graphite is very soft, yet they're both made of carbon atoms. Okay, so that's what allotropes are. Okay, if there's any questions or needs on anything from last week, please let me know. I want you to be successful. Keep working hard and getting your assignments in. Okay, now for this week, you're going to take quiz 2, reactions of saturated and unsaturated hydrocarbons to esters. That's number 4.8. You're going to take a lesson called nitrogen functional groups, 4.9. Proteins and amino acids, 4.10. Application of organic chemistry, 4.11. We've said before that organic chemistry is the study of carbon, okay? Carbon bonds, carbon atoms, but it's not just carbon. I mean, hydrogen's involved with that too, and you also heard me say nitrogen in here. Amino acids are an organic compound because they contain carbon and hydrogen, but they also always contain nitrogen. There's what they call a nitrogen functional group that's always attached to that. So whenever you see an organic molecule that has nitrogen in it, think amino acids and proteins. Okay, very, very important thing. Easy to identify right there. And they have particular shapes, just like I said for what you did last week. You know, you got alcohols, aldehydes, acids, ketones, esters, all of those that are ordinary carbon compounds. Well, among amino acids, you have particular shapes too. The nitrogen groups, nitrogen functional groups, are connected to carbon molecules, carbon atoms, in various ways. And depending on how they're attached, it makes a certain kind of amino acid. Okay, so you can identify the amino acid by where they are attached on the molecule. If there's any questions or needs in there, please let me know. You can contact me through our help chats in the evenings. You can send me an email. You can send something on Hangouts, and I might not get them all immediately, but I'll get them just as soon as I can. I want you to be successful right to the end of the year. Okay, The reflection question for this week is, what is an ester? Okay, I deliberately didn't tell you that at first when I was talking about that particular carbon setup, okay, that particular carbon group. But I want you to identify what an ester is. Okay, you can tell me, you can draw the structure out, whatever. Okay, what is an ester? All right, have a great week. I'm sure we'll be talking again. We'll see you later. Bye now.